Breaking barriers, China's $1.5 billion investment in supersonic technology aims to surpass Concorde's speed records. On March 30, 2025, China made headlines with its ambitious announcement of a $1.5 billion investment in the aerospace sector aimed at developing a new supersonic passenger jet known as the C949. This state-of-the-art aircraft is designed to surpass the speed and range of the legendary Concorde, marking China's significant re-entry into the commercial supersonic aviation market and intensifying competition with ongoing projects in the United States. Key features of the C949. The C949 is outlined in a recent academic paper by engineers from Mach Commercial Aircraft Corporation of China is set to achieve speeds of Mach 1.6, which, while slower than the Concorde's Mach 2.2, compensates with a remarkable range of up to 6,800 miles, an increase of about 50% over the Concorde's maximum range of 4,500 miles. This expanded range allows for non-stop flights between major international destinations such as from Britain to Malaysia. One of the most notable advancements of the C949 is its design that minimizes noise pollution. The aircraft is engineered to produce sonic booms at approximately 89.3 decibels, significantly quieter than the Concorde's 105 decibels. This reduction aims to address regulatory challenges that have historically hindered overland supersonic flights. The C949 features a unique reverse camber fuselage that helps to dampen shockwaves, contributing to a quieter flight experience. The aircraft will accommodate 168 passengers, surpassing the Concorde's capacity of 128. While the C949's top speed is lower than that of its predecessor, its combination of speed, range, and reduced noise positions it as a formidable competitor in the aviation industry. Competitive landscape. China's foray into supersonic aviation coincides with a renewed global interest in this sector, which has seen a decline since the Concorde's retirement in 2003. Companies like Boom Supersonic Spike Aerospace and NASA's partnership with Lockheed Martin for the X-59 jet are all racing to bring their own supersonic models to market. Boom Supersonic recently celebrated successful test flights of its XB-1 prototype, aiming for mainstream commercial service in the near future. The emergence of China's C949 adds a significant player to this competitive landscape. As aircraft manufacturers and aerospace companies worldwide strive to innovate and capture market share, the potential for advancements in aviation technology is substantial. Timeline of events. The development of the C949 is part of a broader strategy by Mach, which was established in 2008. Key milestones in this journey include 2008, establishment of Mach focusing on advancing China's aerospace capabilities. 2024, successful test flight of a prototype by Space Transportation, another Chinese company capable of flying at Mach 4. Indicating China's growing prowess in supersonic technology. March 2025, public unveiling of the C949 project in an academic paper detailing its specifications and capabilities. 2049, targeted entry into service for the C949 aligning with the 100th anniversary of the People's Republic of China. Concerns and implications. While the advancements in supersonic technology present exciting opportunities for the aviation industry, they also raise concerns regarding dual-use capabilities. The technology developed for commercial aviation could potentially be adapted for military purposes, prompting scrutiny from global governments. The U.S. government has already imposed sanctions on Mach due to its affiliations with the People's Liberation Army, highlighting the geopolitical ramifications of China's aerospace ambitions. Industry reactions and future prospects. The announcement of the C949 has garnered mixed reactions within the industry. Blake Scholl, CEO of Boom Supersonic, took to social media to acknowledge the competitive landscape. Folks, it's no surprise. But China has now officially entered the supersonic race. Game on. Let's beat 'em. This sentiment reflects the competitive spirit that characterizes the aerospace sector as companies vie for technological supremacy. Despite the challenges including regulatory hurdles and the technical complexities of supersonic travel, the potential for the C949 to become a mainstream option for travelers is considerable. Industrial forecasts suggest that supersonic travel could accommodate 45 million passengers annually, roughly 1% of global air travel, if regulatory and technological obstacles are successfully navigated. China's commitment to supersonic technology could herald a new era in air travel, addressing both the demand for faster travel and the need for quieter, more environmentally friendly solutions. As the C949 project progresses, it could redefine the future of aviation by accommodating millions of passengers while adhering to evolving noise regulations. Conclusion: China's investment in the C949 supersonic passenger jet represents a bold leap into a domain historically dominated by Western aerospace firms. With its impressive speed, extended range, and reduced noise levels, the C949 is poised to challenge existing technologies and reshape the future of air travel. The ongoing competition among aerospace manufacturers could drive significant advancements in aviation technology, setting the stage for a new era of supersonic travel that meets modern regulatory and passenger needs. As developments unfold, the world will be watching closely to see how this ambitious project evolves and impacts the global aviation landscape. The counterintuitive information in the content regarding China's investment in supersonic technology and the development of the C949 jet includes several points that challenge common perceptions about supersonic travel and China's aerospace capabilities. 1. Speed versus range. While the C949 is designed to travel at Mach 1.6, which is slower than the Concorde's Mach 2.2, it offers a significantly increased range of 6,800 miles compared to the Concorde's 4,500 miles. This might seem counterintuitive, as one might expect a supersonic jet to prioritize speed over range. However, the C949's design emphasizes practical long-distance travel, which could cater to a broader market of passengers who value convenience and comfort over sheer speed. 2. Noise reduction strategies. The C949 aims to reduce sonic booms to approximately 89.3 decibels, significantly quieter than the Concorde's 105 decibels. This focus on noise reduction contradicts the traditional view of supersonic jets as inherently disruptive. By addressing noise concerns, the C949 may enable overland flights that were previously restricted, suggesting that technological advancements can shift regulatory landscapes that have historically limited supersonic travel. 3. Market positioning. The C949's ability to accommodate 168 passengers, which is more than the Concorde's maximum capacity of 128, indicates a shift in focus from exclusive luxury travel to more mainstream commercial viability. This approach counters the notion that supersonic jets are only for the elite, opening up the possibility of making supersonic travel accessible to a larger number of passengers. For geopolitical implications, despite the concerns regarding dual-use technology and military applications, China's entry into the supersonic market with the C949 could be perceived as a peaceful competition aimed at innovation and commercial benefits rather than solely military expansion. This perspective challenges the assumption that advancements in aerospace technology in nations like China are primarily driven by military motives. 5. Industry landscape. The resurgence of interest in supersonic travel after the Concorde's retirement is marked by several U.S. companies such as Boom Supersonic and NASA's X-59 project, yet China's investment in supersonic technology signifies a serious challenge to the existing players in the market. This situation highlights the potential for new entrants to disrupt established markets, contradicting the belief that established companies are safe from competition. 6. Technological synergies with AI. The C949's reliance on an artificial intelligence-powered fly-by-wire system for managing aerodynamics and stability introduces a modern technological aspect that contrasts with traditional aviation design principles. This integration of AI reflects a broader trend where emerging technologies can redefine established industries, suggesting that innovation can come from unexpected directions. 7. Passenger demand. The projection that supersonic travel could accommodate 45 million passengers annually is a significant figure that challenges the skepticism surrounding the demand for such flights. It posits that there is a substantial market interest in supersonic travel, which contradicts the narrative that the market for these jets would be limited due to historical failures and regulatory challenges. In summary, the key counterintuitive aspects of China's C949 project include the prioritization of range over speed, innovative noise reduction strategies, a shift towards mainstream passenger accommodation, the potential peaceful nature of geopolitical competition, the challenge to established industry players, the incorporation of cutting-edge technology, and optimistic projections for passenger demand. These factors collectively redefine the landscape of supersonic aviation and challenge conventional wisdom surrounding the sector. Significant overlooked aspects of China's supersonic investment. While the announcement of China's $1.5 billion investment in supersonic technology and the development of the C949 aircraft has garnered considerable attention, several crucial elements may not be adequately appreciated by the public or analysts. These aspects are significant due to their potential implications for global aviation, international relations, and technological innovation. 1. Technological innovations beyond speed. Many reports focus on the C949's speed and range, however. The technological innovations embedded in its design are equally important. The reverse camber fuselage and shapeshifting design to minimize sonic booms represent a significant advancement in aerodynamics. This technological leap could redefine not only supersonic travel but also conventional aircraft design. The incorporation of an artificial intelligence-powered fly-by-wire system for enhanced stability and control is another noteworthy innovation. Significance: these advancements could lead to breakthroughs that extend beyond supersonic travel, influencing future aircraft designs and operational safety protocols across the aviation industry, which historically has been slow to innovate. 2. Market positioning and passenger capacity. While the C949 is designed for 168 passengers, which exceeds the Concorde's capacity, its primary focus is on mainstream viability rather than niche markets. The decision to target a broader passenger demographic is strategic, aiming to capture a share of the projected 45 million potential supersonic travelers annually. This approach contrasts with competitors like Boom Supersonic, which are focusing on luxury or business class markets. Significance: by aiming for a larger passenger base, China not only positions itself competitively against established firms but also challenges the paradigm of luxury air travel, making supersonic travel more accessible. This could democratize air travel, potentially reshaping market dynamics in the aviation sector. 3. Geopolitical implications and concerns of dual-use technology. The intersection of aerospace technology and military capabilities is a critical concern that is often underreported. The U.S. government has already expressed apprehension regarding the potential military applications of supersonic technology, leading to sanctions against Mach due to its links with the People's Liberation Army. Significance: the dual-use nature of aerospace technology means that advancements in civilian aviation may inadvertently bolster military capabilities. This raises alarms in geopolitical contexts, especially as countries like China enhance their aerospace prowess. The implications for international relations are profound, as nations may feel compelled to respond to perceived threats, leading to an arms race in aviation technology. 4. Regulatory challenges and overcoming historical barriers. The C949 is designed to operate much quieter than the Concorde, addressing the sonic boom issue that historically restricted supersonic flights overland. Reports often overlook the significance of regulatory barriers in aviation, particularly regarding noise pollution and environmental standards. Significance: successfully navigating these regulatory landscapes could pave the way for broader acceptance of supersonic travel globally, potentially leading to a renaissance in high-speed air travel. This success could also influence international aviation regulations, shifting the focus towards more stringent environmental standards that encourage innovation rather than stifle it. 5. The role of state-owned enterprises in innovation. COMAC as a state-owned enterprise represents a model of how government-backed initiatives can drive innovation in critical sectors. This aspect of the C949 project is rarely discussed in depth, particularly in the context of how state support can facilitate rapid advancements in technology. Significance: the C949 project illustrates the effectiveness of state investment in fostering technological innovation and competitive advantage in global markets. This model may inspire other nations to reconsider their approaches to aerospace development and funding, potentially leading to an increase in state-sponsored research and development initiatives worldwide. 6. Environmental considerations and future sustainability. While the C949's design aims to minimize noise, the environmental impact of supersonic travel is often not fully addressed. As global aviation faces pressure to reduce carbon emissions, the sustainability of supersonic jets remains an open question. Significance: the industry's response to environmental concerns will shape the future of aviation. If the C949 can demonstrate that supersonic travel can be both efficient and environmentally friendly, it may set a precedent for future aviation technologies, influencing regulatory frameworks and consumer acceptance. 7. Implications for global competitiveness. China's entry into the supersonic market not only re-establishes its presence but also intensifies competition with US and other Western companies. This competitive landscape is often perceived through the lens of technological rivalry but overlooks deeper economic implications. Significance: the race for supremacy in aerospace technology could lead to significant investments in research and development, potentially creating new jobs and economic opportunities in both China and competing nations. This competition may also spur collaboration in areas such as environmental sustainability and safety standards, benefiting global aviation collectively. Conclusion: the investment in the C949 and the broader implications of China's foray into supersonic technology extend well beyond the immediate benefits of speed and range. The technological innovations, market positioning strategies, geopolitical ramifications, regulatory challenges, state involvement in innovation, environmental considerations, and competitive dynamics are all facets that warrant deeper scrutiny. Understanding these elements is essential for grasping the full impact of China's ambitions in the aerospace sector and the potential ripples this investment may create across the globe. 1. Technological innovations and design features of the C949. The C949 represents a significant leap in supersonic aircraft design with its unique reverse camber fuselage, which minimizes sonic booms to approximately 89.3 decibels, a notable improvement over the Concorde's 105 decibels. This technological advancement seeks to address regulatory challenges that have historically limited supersonic flight over land. Additionally, the aircraft's projected speed of Mach 1.6, while slower than the Concorde, allows for an increased range of 6,800 miles, catering to longer nonstop flights. These innovations not only position the C949 as a competitive aircraft in the market but also highlight China's commitment to advancing aerospace technology. 2. Competitive landscape and market dynamics. The resurgence of interest in supersonic travel has led to increased competition, with companies like Boom Supersonic Spike Aerospace and NASA's partnership with Lockheed Martin developing their own supersonic projects. China's entry into this space with the C949 adds a new layer of competition, particularly as it aims to capture a significant portion of the 45 million potential annual supersonic passengers. The competitive landscape underscores the urgency for innovation and efficiency in commercial aviation, as established players are now challenged by a state-owned enterprise that seeks to redefine the market. 3. Geopolitical and regulatory implications. China's investment in supersonic technology raises concerns regarding its dual-use capabilities, particularly in relation to military applications. The U.S. government's sanctions on COMAC due to its ties with the People's Liberation Army reflect the geopolitical tensions that can arise from advancements in aerospace technology. This situation poses questions regarding international regulations and the potential for an arms race in aviation technology as countries seek to leverage advancements for both commercial and military purposes. The implications extend beyond aviation, affecting global trade and diplomatic relations as nations respond to China's ambitions. 4. Future of supersonic travel and environmental considerations. The C949's design aims to accommodate a large number of passengers while addressing environmental concerns associated with supersonic flights. With a capacity for 168 passengers, the C949 is intended for mainstream viability, contrasting with the more limited seating of the Concorde. Furthermore, the focus on reducing noise pollution through innovative design addresses key regulatory barriers that have hindered the reintroduction of supersonic flights. This move towards environmentally conscious design reflects a broader industry trend towards sustainability and could reshape the future of air travel, making supersonic travel more accessible and acceptable to the public. Here are 3 famous historical cases that resonate with the theme of breaking barriers in aviation and technological advancements, specifically regarding supersonic flight and innovation. 1. The Concorde, a landmark in supersonic aviation. The Concorde, developed by a partnership between British and French aerospace engineers, was a pioneering supersonic passenger aircraft that entered service in 1976. It was capable of reaching speeds of Mach 2.0 for approximately 1,354 miles per hour and flying at altitudes of 60,000 feet. The Concorde significantly reduced travel time, allowing passengers to fly from London to New York in under 4 hours. However, despite its technological achievements, the Concorde faced significant challenges, including high operational costs, noise regulations due to its sonic booms, and a limited market. The Concorde was eventually retired in 2003, marking the end of the era of commercial supersonic travel. Its legacy, however, continues to inspire new developments in supersonic technology such as China's C949. 2. The Boeing 747, redefining commercial air travel. The Boeing 747, introduced in 1970, revolutionized air travel with its distinctive humpback design and ability to carry a large number of passengers, initially up to 400, later models accommodating over 600. Dubbed the Jumbo Jet, the 747 made air travel accessible to the masses and significantly reduced the cost per seat mile. By breaking the barriers of capacity and efficiency, it transformed the aviation industry, leading to increased tourism and global connectivity. The success of the 747 inspired further innovations in commercial aviation, prompting competitors to enhance their designs and introduce larger, more efficient aircraft. The Boeing 747 remains an iconic symbol of air travel innovation. 3. The Space Shuttle program, pushing the boundaries of space exploration. NASA's Space Shuttle program, active from 1981 to 2011, was a significant advancement in reusable spacecraft technology. The program enabled the launch and repair of satellites, construction of the International Space Station (ISS), and deployment of scientific instruments into orbit. The Space Shuttle's ability to carry astronauts and cargo into space and return to Earth marked a significant milestone in aerospace technology. It broke barriers not only in terms of launch capabilities and mission flexibility, but also in fostering international collaboration in space exploration. The program's legacy continues to influence current and future space missions, including plans for Mars exploration and beyond. These historical cases illustrate the pivotal role of technological advancements in aviation and space exploration, highlighting the challenges and triumphs that come with breaking barriers in these fields. In the context of China's $1.5 billion investment in supersonic technology, particularly the development of the C949 jet, the future of aviation appears poised for a transformative shift. Here are several predictions for how this investment and the broader landscape of supersonic flight might evolve over the coming decades. 1. Revitalization of supersonic travel. The C949's development signals a resurgence in interest in commercial supersonic travel, which had largely been dormant since the retirement of the Concorde in 2003. With a focus on achieving greater efficiency, range, and reduced noise levels, supersonic jets are likely to re-enter mainstream commercial aviation by the late 2020s or early 2030s. By that time, technological advancements may facilitate larger fleets of supersonic aircraft operating transcontinental routes, significantly reducing travel times. 2. Increased competition. China's entry into the supersonic market will intensify competition with American firms like Boom Supersonic and government projects like NASA's X-59. This rivalry could catalyze rapid technological advancements and lower costs for consumers. As companies race to perfect quieter and more efficient supersonic jets, we may see innovations such as advanced materials and engineering techniques that further enhance aircraft performance. 3. Regulatory changes. To accommodate the new generation of supersonic aircraft, regulatory frameworks will need to evolve. Given the C949's design to minimize sonic booms, it is possible that international aviation authorities will begin to reconsider the restrictions that have historically limited overland supersonic flights. If successful, this could lead to more flexible airspace regulations, enabling supersonic flights over land and expanding route options for airlines. 4. Environmental considerations. As the aviation industry faces increasing scrutiny over its environmental impact, the focus on sustainable practices will likely reshape the future of supersonic travel. Companies may integrate sustainable aviation fuels (SAFs) and carbon-neutral technologies into their operations. The demand for low-emission supersonic aircraft will push manufacturers to innovate further, possibly leading to hybrid or fully electric supersonic designs by the 2040s. 5. Global connectivity and economic impact. The introduction of the C949 and its competitors could significantly enhance global connectivity. With faster travel times, airlines could open up new routes that were previously unfeasible. This increased accessibility is likely to stimulate tourism and business travel, promoting economic growth in regions that are connected by these supersonic flights. Estimates suggest that supersonic travel could cater to approximately 45 million passengers annually, representing a notable segment of the aviation market. 6. Military applications and geopolitical tensions. The dual-use nature of supersonic technology, as highlighted by concerns over its military applications, may lead to heightened geopolitical tensions. Nations may race to develop their own supersonic capabilities, potentially leading to arms races or conflicts over air superiority. This aspect will require careful monitoring and international dialogue to mitigate risks associated with military applications of civilian technology. 7. Consumer adoption and market dynamics. The success of the C949 and its competitors will heavily rely on consumer acceptance and market dynamics. Airlines will need to balance ticket pricing with operational costs, ensuring that supersonic travel remains attractive to business and leisure travelers. The emergence of a luxury travel segment that embraces supersonic speed could also redefine premium offerings in the airline industry, catering to affluent consumers willing to pay for faster travel. 8. Technological innovations beyond supersonic. The advancements made through the development of supersonic jets may spill over into other areas of aviation technology. Innovations in aerodynamics, noise reduction, and materials science could enhance the performance of conventional subsonic aircraft as well. The collaborative efforts across the aviation sector may accelerate the development of next-generation aircraft, including electric and hybrid models. Conclusion. China's substantial investment in supersonic technology is set to reshape the future of aviation in profound ways. From revitalizing commercial air travel to driving advancements in sustainability and technology, the coming decades will likely witness a renaissance in how we perceive and experience air travel. As the C949 project progresses, the competitive landscape and regulatory frameworks will evolve, presenting both challenges and opportunities for stakeholders across the aviation industry.